them to engage with clients, as well as, you know, we can hold sweepstakes. We do a lot of social media platform stuff across Facebook and across Twitter.
Content.
Yeah, user-generated content.
So if you want to post some photos, and we have a gallery, if you do hashtag Offerpop meetups and hashtag Ansible, then you guys can have all the pictures and content from this meetup.
Cool. Awesome.
Apparently, one way to get people viral, by the way, I just learned since I've been on the job, is to basically hashtag anything gay.
Yes.
Or hashtag, I don't know, Justin Bieber, Mike Alvin.
We've done that. Hashtag Offerpop Justin Bieber.
Yeah, that would die, please. That's a really good feature. But anyway, hey, Walter.
All right, Walter, thanks.
So by the way, if you need, sorry, Walter, if you need Wi-Fi, it's Offerpop Meetup, or Meetup Offerpop, and then the password is Meetup 2015.
Yay.
Well, first off, thank you, Offerpop, for allowing me to be here in the Meetup group as well, the Ansible Meetup group. I'm very excited. A few things of transparency I'm going to be open and honest about. If you're planning to go to Ansible Fest, you're going to hear this presentation again because I'm actually using you guys as my cold warm-up to that. So I'm definitely welcoming feedback. If there's something about it you didn't like or something you like about it, please let me know. And if you are going to Ansible Fest in London, then sorry, you just have to hear me give it again. But I'm being totally transparent about that. So if you're not going, you get to hear one of the presentations from Ansible Fest. If you are going, you'll see me again. Other thing I wanted to say is that Ansible is very nice to send us some swag. Please feel free to take advantage of it. T-shirts, stickers over there. Really good about that. Definitely put the T-shirt on, tweet it, hashtag Ansible. They will love you for that, okay? So, kind of get into some things. So my name is Walter Bentley. I am a Rackspace Private Cloud Solution Architect. That's what RPC stands for. So you may hear me say that a few times, but RPC is basically Rackspace Private Cloud that's built on OpenStack. My sole purpose in life is to build clouds for customers built on OpenStack. So that's what I do every day. Here's my other information. My Twitter is @DJStayFlyPro. Yes, I am a DJ, but I'm not a DJ because I don't actually do it actively now, but I was a DJ. And there's some other information I have up there. I have a blog post as well.
You're still fly though, right?
I'm still fly, just not much of a DJ at the moment. So, so just a little bit about me really quickly. Who am I? So I've been in IT for about 17 years now. I started out as a Microsoft ASP developer. That just shows you how long ago that was, right? When ASP was not even ASPX, we're talking about ASP. Very quickly realized that I did not have the chops for a developer. Primarily after I spent 3 months developing something and handed it to my boss, and he told me no thanks. After they asked me to develop it, of course. So I transitioned into doing more application support, and I primarily focused on web support. And I primarily focused on web support based off of Windows systems. So basically over the majority of my career, I spent time being a production support engineer, meaning the guy that you call 2 o'clock in the morning to remediate a problem. So when I started to look at Ansible, and I'll go a little more about it later in detail, what Ansible offers production support engineer or infrastructure engineer, that's really what attracted me to Ansible. And I'm going to go into some more detail of that. Here's some of the companies I work for. None of them are really, really big. If you love JetBlue, great, fly them. They're a wonderful company. And of course, everyone, if you were born and raised in New York, everyone knows who the New York City Board of Education is. So, how did we get here? How did Rackspace get to the point where they were looking at Ansible? You know, what drove Rackspace to look at Ansible? Not just to use it internally, but also what drove us to build our product? Because we built our whole new product release around using Ansible. So what drove us here? So back in 2014, Rackspace embarked on the journey of developing a new RPC version. So at that time, its current version was RPT 4.2, which was built off the Havana release of OpenStack, and we knew we needed to go to Icehouse. Before going to that and releasing that new release, we ran into a lot of issues, a lot of lessons that we learned when we deployed Havana. Customers gave a lot of feedback, we encountered a lot of problems, somewhere spanning from performance issues to scalability issues, and the biggest one, which is deployment issues, being able to deploy that cloud in a functional and easily repeatable manner. So when we went to build the new reference architecture, clicker is not working. Probably need to go to the other side of the TV. Sorry. So when we built the reference architecture, there were four pillars we built it off of: stability, scalability, automation, flexibility, and a hybrid approach. And I'll break some of those down really quickly in more detail. So stability and scalability, the ability to be able to deploy our private cloud over and over again and be able to scale it out without having to rewrite the deployment scripts or deployment process. And one thing I forgot to mention is that our previous versions of Rackspace Private Cloud was deployed and built using Chef. So we actually made a transition from Chef to Ansible, and we'll go into some more conscious decisions why we did that. Automation, so being able to repeatedly build clouds. So we're in the business of building clouds for customers, whether it be on their premise or in our data center. And as you can imagine, that is a process that we repeat and constantly do over and over again. So it had to be something that could be automated and done very quickly. It had to be flexible. Customers constantly come back and say we need more compute nodes, or we want to deploy Swift now, or we want to use Cinder now. We have to have the flexibility of being able to bring those projects back into their private cloud without it being extremely difficult, right? And of course, hybrid. Rackspace, openly and honestly, we do have a public cloud, just as well as Amazon and those other guys. And we do encourage our customers to use our public cloud as well as private clouds to be able to kind of create a hybrid approach. So we had to figure out how can we do that and make that an easy thing that we can accomplish. Clicker's being mean to me today. It worked perfect the other day. Yeah, now it's skipping. See, it's doing special stuff. All right, we're going to have to go back old school, I think. That's fine. So, anyway. So just take a really quick look at our reference architecture that we're using to build OpenStack. And the reason why I'm showing you this, not because I'm trying to sell you RPC per se, is primarily because I wanted to demonstrate that in order to have a highly available, production-ready OpenStack cloud, you need multiple servers. You're not building this on one server. It's not a dev stack. It's not something you're running on one server, right? To have a highly available, scalable production OpenStack cloud, you need multiple servers. And I did this to show that you're running multiple servers all running together that have to run in the ecosystem. Now imagine doing this, and this is one of the simplest designs, and each of these rectangles here are actually a server. So this is just a small footprint. Imagine doing this over and over again for hundreds of customers. We're talking about hundreds of servers and having to be able to manage and deploy OpenStack onto those servers easily. It's not an easy task. We need to be able to make it so that it's a repeatable process that didn't require high-level engineers to be able to do. So this is why Ansible. So the question is, so why Ansible? Why did Rackspace look at Ansible? These are just some of the bullet points as to what drove us to want to look at Ansible. Obviously, you guys are familiar with it, so I don't have to really go through them. But these are just some of the high-level ones that you're probably very familiar with. Clarity and ease of use. Creating playbooks is highly accessible for developers, meaning it's written in a language you can actually understand. Other groups in Rackspace are already using Ansible, so we were actually using Ansible prior to launching our latest version of our Rackspace Private Cloud, and it just made sense. As well as we had a relationship with Ansible, as you probably know, that getting along with Ansible is actually very easy. They're very responsive, and they're very open to input, and that's one of the things that drew us to them. The existing modules that they already had created to work with OpenStack drew us to it. Even though I'm open and honest, we don't really use those in our playbooks, I'll be honest, but that's irrelevant. Ease of use and configuration, no agent needed, and of course, being able to do upgrades and upgrades to the different versions of Ansible without actually having to do, you can do them in isolation without having to mix them in, go and worry about different versions that are running. So these are just some of our high-level reasons as to why we chose Ansible. Yes. So, one thing I forgot to say is that if there's a question or a comment that you have, please stop me. I do talk fast, so it helps slow me down. So if you have any questions, feel free to disturb me. It's no problem at all.
I have one actually.
Please.
The existing Ansible modules for OpenStack, you said you're not using those. Have you open sourced the ones that you are using, or can customers use those?
Yeah, well, I'm going to go into that, but I'll mention it now, and I'll repeat to mention it because I like saying it, is that all of the playbooks that we use to create and deploy, all the playbooks we use to deploy our Rackspace Private Cloud or OpenStack Cloud are all open source. They're actually on GitHub. They're free of charge. You can download them. You can deploy your own OpenStack Cloud. You don't ever have to talk to us. Primarily because obviously OpenStack is not something we own, it's open source. Even though we helped create it with partnering with NASA, we open sourced it years ago, back in 2010. And we feel that we should not make money off of something that is free. So our playbooks are actually on GitHub. I'll share the link where you can pull them down. And feel free to use them to build a cloud. I mean, you can build a really small cloud, or you can even use them to build a big cloud in your own data centers.
Is there a reason why you're not using the Ansible modules?
I can't say there was a particular reason other than the fact that the complexity of rolling out OpenStack and all the projects, there is not a module in Ansible for every project that is an OpenStack. They cover the main ones like Nova, and I think it's Glance, and a few of the others, but not all of them. So that kind of limited us. And also too, when you're installing OpenStack, you don't necessarily need the modules, right? The modules are after you've installed OpenStack, then being able to manage OpenStack using Ansible. We're actually installing it, so it kind of put us in a different place with that. So kind of going into some of the stuff about why I love Ansible. So I'll be open and honest to say that I work for a company that uses Ansible, but I actually fell in love with Ansible before coming to Rackspace. So the quick story around that is that I used to work for JetBlue Airways, as it was up there, and we were embarking on doing a lot of DevOps, embarking on using the cloud, and they made a decision to go with Puppet. And I began to start digging in and learning about Puppet, and as I started having talks with Rackspace, they quickly brought to my attention that, yeah, you're going to be dealing with OpenStack Cloud, and we use Chef. And I said, oh my God. Now I just learning Puppet, now I gotta go learn Chef, and I had no desire whatsoever to learn Chef. I was actually very upset that I had to go and learn Chef. And truth be told, do I have to learn Chef? No, but in order for me to be successful at my job, as successful as I prefer to be, I would have to learn Chef. The good news is that the day that I started, or the week that I started, they announced that they were going to be building our new cloud on Ansible. And I was ecstatic, because now I said, you know what, I understand Ansible, I can work with Ansible, it makes sense to me, I don't have to learn Chef. I was very happy. So that's how I kind of fell in love with Ansible, and then as I began to use it more to automate things that I was doing, such as being able to build clouds quickly on my laptop to demonstrate for customers, because my use case is a little bit different. I'm building OpenStack continuously to demo for customers, and it's kind of a hard thing to do when you have to raise your hand here, whoever built OpenStack before. It's not something you would just do in 5 minutes. It takes hours and times, and it doesn't always work the same way, right? So I had to figure out a way to be able to do that, tear that environment down, build it again, tear it down, build it again, and do that very quickly. So I was actually using Ansible to do it. Another thing, one of the things that I love about it is that it is open source. I don't have to pay for it. I hate paying for software. I'm a Microsoft guy. I've done it for all my life. I paid for software all my life. I don't want to do it anymore. So I love the fact that the Ansible is open source. I love the fact that Ansible's goal was, and it actually is on their website, and they'll tell you this first and foremost, is that their foremost goal was simplicity and maximum ease of use. So they created their software to be easy to use. You gotta love that, especially if you're an IT person who's done this for many years. Anything easy to use is something you're going to gravitate toward. The fact that the code is written in YAML format, to me YAML's godsend. I don't really like having to decrypt a programming language. I want it to be in pure English. I love formatting, which is why I love best practices. So I love the fact that Ansible gives you best practices out the gate. You can go to their website, and they actually have a page that's called Best Practices. That'll tell you all the things that you need to know before starting with Ansible. Can't say that I saw that with Puppet, Chef, or any of the other ones. So it kind of makes me smile. So before we go into some of the under the cover stuff, and again, it's not really, it's top secret because again, as I shared, it's open source, right? It's out there on GitHub. You can download it and tear it apart and build it again and do whatever you want to the playbooks. You can have your name written across the top every time you run one of them, whatever you want. But I figured I would give you guys kind of a leg up as to some of our playbooks and roles and how we're using them and what it kind of is framed up around. And I also will give you some more information about some of the stuff that I've added to it that I've done in Ansible as well. So this is not top secret, it is kind of sort of top secret. So our playbooks to build an OpenStack private cloud are really broken down into 3 different main playbooks. And of course underneath that playbook there are multiple roles and configuration files and things of that nature that kind of help to deployment. But there are really 3 main playbooks that are run. This one I'm not counting, that's why you see 4 and not 3, is the HA proxy one is an optional playbook that you can run. Let's say, for example, you want to deploy this private, deploy RPC, bless you, on a laptop or in a place where you didn't have an actual physical load balancer, you would run the HA proxy playbook, and it would actually do the configuration to do the load balancing. Part of our reference architecture with our RPC build is that we have multiple control planes, so you need a load balancer to be able to balance load. You may or may not know this, OpenStack does not do that automatically for you, so that's something you have to do. But the other three main playbooks are host setup, infrastructure setup, and then of course OpenStack setup. So to kind of break down these, very briefly kind of talking through them. So the host setup playbook, basically all it does is it preps your host to be able to be ready to install OpenStack. It installs whatever additional software that's needed, prepping it, because we are using LSC containers to deploy on OpenStack. We actually have each OpenStack project in a container itself. So it preps the host to be able to have containers running, and it does a lot of the back-end things that need to get done. The infrastructure setup playbook actually just goes in and installs the base infrastructure components that are needed. We use MariaDB as our backend for OpenStack, RabbitMQ, and we also install a series of the ELK stack as well to do log aggregation and things like that. So the infrastructure setup basically installs those base pieces of software that you need to run your OpenStack cloud. And of course, last but not least, is the OpenStack setup. This playbook actually will install every single project that's available in the OpenStack. So we're talking about Keystone, Glance, Neutron, Nova, Cinder. It will do Swift, as well as it will do Heat and Trove. We're not exactly onto the newer projects yet in OpenStack, but it will handle all of those currently. Actually, I kind of lied. Trove is not one of those yet, but it will be first week of February. That's aside. Because we're releasing actually version 10 of RPC Cloud first week of February. But when you're looking at the instructions, and instructions that we have, and I'm going to show you a link on that, it's actually 72 pages of instructions to install it, even using Ansible, right? But out of all the 72 pages, this is really the guts of what you really care about. All the rest of the stuff is a lot of prepping and things like that, and I'm going to show you how I solved for some of that problem as well. Yes?
When you guys started using Ansible to do the deployment of version 9, did you do it with future-proofing, knowing that like every 6 months OpenStack is going to come out with a new release and being able to upgrade your cloud to version 10 easily, quote-unquote easily? Yeah.
Well, yeah, and that was the primary reason why we are deploying the OpenStack APIs into containers. So we're using Ubuntu 14.04 and we're using LXC because that's native as part of that OS. And the reason why we're putting them in containers is for that very reason. Is to be able to do easy upgrades, because OpenStack does release, make a mid-release every 6 months, to be able to upgrade that in place. Right now what we were doing with our older versions is you have to stand up a duplicate cloud next to it, and folks have to migrate. The most painful process, and that's all I've spent my week on, is talking to a customer off the ledge about doing that process. So with the containers, what we can do now with LXC containers, we can just build new LXC containers, pop those onto that same machine, do some other, behind-the-scenes stuff to be able to upgrade and migrate, and then turn off the other containers, and now you're running Juno. So that's the reason why we did that. But it wasn't really, Ansible is not really, well, Ansible is indirectly helping us solve for that, because we don't have playbooks to help do that.
A little off topic for Ansible, but with Juno, I have to, if I want to run a Red Hat-based OS, I have to run Red 7 or CentOS 7. Does running the containers help me kind of alleviate that requirement, so I can still, I don't have to re-image my base system? I can just deploy the new container with the Rails 7 environment, basically, or do I still have to upgrade my bare metal host?
Now, are you talking about the instance or the bare metal host?
The bare metal host itself.
Yeah. See, again, and this is where I'm not going to speak for what our competitors do and don't do. Red Hat. But the reality is that because we are using containers, so the actual OpenStack API or OpenStack base is not actually installed on the base bare metal machine.
Yeah.
It's actually in the containers. So the base machine doesn't know anything about OpenStack. It doesn't even care. I can't speak what the other competitors do, but the reason why we went with containers is so that upgrade can be in place and easier.
Yeah.
And that's you can do in-place upgrades with OpenStack, which is a whole other topic. We're not going to get into that, but I have not seen one go successfully yet.
Okay.
Say it that way. Something bad always happens. So this is the basis of what you're going to be looking for to be able to deploy your private cloud. And there's two config files that are absolutely the most important things in the world to you when you use these two config files, rpc_user_config and user_variables_config, and I'll explain why. This rpc user config variable file is one where you will tell Ansible what components to install and where to install them. And it goes through every component. It goes through defining IP spaces. I mean, it's so detailed out, it's unreal. But what that does is that, let's say, for example, a customer has already deployed 4 compute nodes and they want 2 more. All I have to do is go into that file, add the 2 more, and run it just for those two new servers, the playbook just for those 2 new servers with a dash, I think it's a -L, and it'll just deploy on those 2 servers, and I won't have to do anything else. So that's the power behind having it distributed the way they did. The user variables file is where you would store, you would set all your passwords that you want to set up for each OpenStack project, for your MariaDB and things like that. So it's all stored in one place. Again, you make a change there, you run your playbook again, it'll make the changes everywhere. So that's one of the flexible components around that. So as I mentioned, there's a 62-page document online that'll walk you through how to install RPC using Ansible. And I do mean 62 pages. Out of the 62 pages, 35 of those pages are solely pre-configuration steps, meaning they are not steps that you actually need to take to install OpenStack. And so me being the guy that I am, you know, if you're going to do it one time, no problem. You don't care, right? It's no big deal. If you're going to just do this one time, you'll step through these 62 pages and it won't live. Unfortunately for me, I do this every day. No bueno. It's no good. There's no way in the world that I want to step through 35 pages of pre-implementation stuff right before I get to the actual running of those 3 playbooks. That's absolutely not in my wheelhouse to do. So I came up with a bright idea. It doesn't look like a good idea, right? My idea was a little bit better. It was more around, well, why not create roles and playbooks to automate all those pre-configuration steps? You know, my coworkers laughed at me, and I literally mean they laughed at me. Number one, because I actually do live demos for customers, and they don't, but me being the crazy guy I am. And then secondly, they said, why would you spend all your time doing that? And I said, well, because I can do live demos for your customers now. You can't. So I said, you know what, let me take some time and figure out how to make all those pre-configuration steps, frame them up into Ansible playbooks and roles, so that I can run those, then run those 3 Ansible playbooks that are default part of the build, and I'm done. So I did that. And the good news is, I'm willing to share them with you guys. So what I did is I created some playbooks to be able to handle not only being able to deploy locally on a laptop, so if you're so you can use Vagrant, VirtualBox, and of course Ansible to deploy our OpenStack private cloud on your laptop, or if you wanted to deploy it on a Rackspace public cloud. Now, one thing I will say is that the second one, it is classified. I will repeat it. I do not encourage you to deploy Rackspace or private cloud on our public cloud. Can you do it? Yes, I'm not encouraging you to do it. And if you really want to do it because you want to play with it, talk to me afterward and we'll exchange some money. And I'll give you those playbooks as well. I have those as well. Okay, but seriously, yeah, it is a possibility. You can do it, but I wouldn't encourage you to do it. So I don't know if you guys want to take write this down. I will put some of this info out there. I'm not going to put it all out there primarily because I am giving a talk at Ansible Fest the first week of February, and I don't want to put spoilers out there. But I can share some of this information with you as well. And these work because I use them personally every day. I'll let you take some tickets. And if you have a problem with it, don't call me. I'm just kidding. You know, let me know, and I'll help you figure out.
So, what is the difference between the 2 reports?
Okay, so that's a good question. So one thing I probably didn't explain, so with Rackspace Private Cloud, the way we deploy our cloud is we actually stand up a deployment server, and that deployment server is where Ansible is installed, and that server actually manages deploying that private cloud. So every private cloud gets a deployment server. The deployment server has different requirements versus the actual machines that are going to receive OpenStack. And I could have kept them together, but I felt it was easier to make them separate because they actually are 2 separate things. once your cloud is up, you can actually destroy your deployment server. You don't need it anymore. But at the same time, I don't like co-mingling the two, and the requirements were so different that I didn't feel comfortable making it one. Maybe that's something I can challenge you guys with to figure out how to make it one playbook instead of two. But I live with my two. So one is to set up your deployment server and everything needed for it, and then the other one is to set up all the other host machines that are going to receive OpenStack.
Does that second one need to run on the deployment server, or only those 3 scripts that you showed us earlier run for that deployment server?
So that's a really good question. So neither of them. So to answer your question, it does not need to run on a deployment server. Both these are run independently. They can run locally from your laptop. And the same thing with the public cloud one. If I share it with you, the same logic goes. You run it locally from your laptop. You don't have to run. These are to prep the machines. The other playbooks that we talked about are the ones that are actually run from the deployment server. And then 72 or 62 page instructions will explain that as well. Cool. So back in not too long ago, last year at the Paris summit that we had, the OpenStack summit that was held in Paris, there became a lot of conversation around standardization. So OpenStack is very big on standardizing on different builds. They like to have a standard build to build OpenStack with Chef. They like to have one to build with Puppet. So then the question came up, well, is there a standardized build to deploy OpenStack using Ansible? And of course, they started having conversations with us, and we went back and forth with the user community. And the great announcement came out after that is that back in November, the OpenStack community actually voted to accept the playbooks that Rackspace created into the StackForge repository, making our builds the basis for Ansible support for supporting OpenStack going forward. So we were very happy about this, very privileged. And basically what that means in the big nutshell is that Ansible, if you're going to deploy OpenStack, the OpenStack community supports using our playbooks to deploy it using Ansible. So that's the bottom line. So if you ever go to OpenStack community and say, I want to deploy OpenStack using Ansible, they're going to point you to our StackForge. And what we did is instead of maintaining what Rackspace does and then maintaining what we give to StackForge, we made a decision to have only one. So everything that we deploy, every change we make to our playbooks to deploy OpenStack, we put out in StackForge. So you see them live as we're developing them. And if you go on there right now, you'll see that we're already at version 10, which is coming out first week of February. So there's no hidden agenda. Everything is right out there in the open. This is the information about that community vote, and this is actually just some more details around the actual StackForge location and things like that. If you are interested in putting in a bug or just seeing the code itself. So, kind of going more in detail of that, my next slide basically just says, we were very happy about that, and made us want to sing a little bit about that change. That community alignment and being able to put that out there and have the Ansible community be able to build and contribute to it, as well as Rackspace. That's really what we aim to do at Rackspace. We like that community feel. We like to work with others, and we're not really about taking ownership of everything. It's more about spreading love and everybody coming together to make it work. So that made us very happy. So here's some of the more details around our Rackspace Private Cloud. So this is the actual link to that 62-page or 65-page install document that I was referring to. If that was something you were interested in actually installing Private Cloud, you can go here and get some point-by-point instructions. Just as a side note, if you use my playbooks, you can skip all the way to chapter 6. Never mind chapters 1 through 5, you don't have to read them. And you go right to chapter 6, and that's where those 3 playbooks that we mentioned earlier will start to kick in. The second one is again from the previous slide. This is actually the repo on GitHub where the Ansible playbooks are stored. Feel free to pop in there, report bugs, yell at people. Actually, if you report a bug, it actually goes to my coworker who I laugh at all the time because he gets very frustrated. So please report bugs. And make sure you hit me up on Twitter after you do it so I can ask him how the day is going. So I encourage it. So I just wanted to now open up to some more question and answers if you have for me. I mean, that's actually all of my content. Hope I didn't blow through it too fast. Almost 30 minutes. You know, if you had any questions for me, I'm more than willing to answer them. Yes?
The two pre-deployment or preparation scripts that you've got the playbooks, do those also have the same dependencies on the user variables and the hosts?
No, no. Those are totally, they're totally separate from the playbooks you can pull down from Stack Forwards. They were just my add-ons to make life easier. Part of the process is, you know, you have to, you know, so for example, in the one running locally, I'm using VirtualBox, so I basically have a vagrant script that allows, it talks into VirtualBox, stands up the instances you need, gives it the right memory, connects it to the right networks. Then it kicks off a whole bunch of playbooks that will go in and do all the prep work that is needed for that actual host. Because running Ubuntu 14.04 and VirtualBox, it needs certain things that are different than if you would want to do it on an actual physical bare-bone machine or actually even doing it in a cloud. It actually has different requirements. So that was some of the stuff I did there. Same thing with the public cloud version of it. I'm going in, spinning out cloud instances, using our public cloud API, configuring those, whatever they need to do, and then I'm ready. I can log into the deployment server and start right at chapter 6, right at that first playbook, and start installing OpenStack. Yes?
If you're doing a new install for a customer from bare metal on up, how long does it take, like with prep in now with Ansible, as opposed to how long it took before when you guys were using like Chef? What's the time diff?
Gotcha. Yeah, so I think right now we're able to walk into a customer's data center, bearing in mind that they've stacked and racked and their network setup is solid. Within 2 days, and I only say when I say 2 days, there's always something you're going to run into. There's always going to be one machine that's not cooperative. There's always going to be one NIC or switch port that's not doing what it's supposed to do. So within 2 days, we can walk in and out of a customer's DC and employ n number of size of compute nodes for OpenStack Cloud. Versus Chef, every time we did it, it was like custom. We never felt it was a repeatable process, ever. Which is a problem, obviously. Right? Yes.
So, as a pretty new OpenStack user, operator, so, you know, I started off with, I just want to use, like, Cinder and compute and kind of the bare minimum, and then I wanted to add stuff. Talk a little bit about how Ansible helps with either adding on later or making config changes, like, oh, I totally messed up my network config when I first did this. Now I kind of need to redeploy it. So I know how to do that in Chef right now, but what are how easy is it with Ansible? Like, what are some of the changes? Is it difficult, time consuming,
Right.
risk prone?
Right. No, it's actually very easy.
It takes the changes and it executes on changes on the. Sorry.
No. You're spot on. It's very easy, particularly with the playbooks that we've developed. You can run any one of those playbooks over and over again. It doesn't care. It doesn't get hung up with saying, oh, you did that already, I'm not going to continue forward. And that's one of the things that we spent a lot of time on developing so that it would not have that problem. So let's say, for example, you mess up, and this is something I've done before too, is messing with Keystone. I've gone in and misconfigured something, and now I can't, none of my other projects will authenticate, right? So I can't, you're basically hosed, right? I can actually go in and kick off the Keystone playbook directly, because within inside those 3 playbooks that I showed, you know, when you look at the code, inside that playbook, obviously it's another playbook that calls another set of roles. If you go right after the Keystone playbook, and it's just run that, it'll actually rerun and install everything all over again. Back in the day, Chef did not give us that flexibility at all.
Do you guys use tags a lot to be able to control, like, to be able to run specific parts? So when I worked on a bunch of stuff for Hadoop clusters, we used tags significantly to be able to say, well, I only want to update Zookeeper, or I only want to update, you know, my HDFS or something like that. Are you guys using that in your playbooks?
Yeah, we are using tags, as well as you'll find that our playbooks are very distributed. We kept to the theory that Ansible says, which is to keep it as simple as possible. So every component that needs to be installed is actually a separate playbook, which has a separate set of roles, right? So you could use tags, or you can go after the distinct components that you need and not have to worry about the rest. And yeah, so yes, so you have the flexibility of doing either one.
Cool.
You know, I generally, if I'm having a problem with a specific component, like I've had to reinstall MariaDB sometimes because it, you know, anyway, I've had to do it
Yeah.
multiple times. I'll just go after and reinstall that guy and then rerun it, whatever OpenStack playbooks, and it will go in and, you know, with Ansible it's really good, right? If it sees that something is done already, it's not going to do it again. If it needs to be done again, like creating a database, creating a user, it'll just go and do it again. So yeah, I find that you can rerun these playbooks over and over again, and I've actually physically done it. Yes.
To play with these playbooks, the minimum number of machines, I know OpenStack probably takes a lot, I've done it in the past with RDO. And basically, how many machines do you think these playbooks I will need for successfully completely test it?
Right. So I've actually, so our reference architecture requires 4 control plane servers and at least 2 compute nodes, right? Obviously, if you're running this on your laptop, that's very hard to meet. I mean, I have 16 gig on my laptop, and I couldn't obviously not meet that. So I have successfully deployed our reference architecture with 1 infrastructure node and 1 compute node. I've stripped out other things like the logging server. Like we have a server dedicated just for aggregating logs. And as a side note, if you're going to actually use the playbooks that I created to do it locally on your laptop, strip out the logging server. What you'll find is that you'll deploy it, it'll go through fine, but you can't use it because it's so, your machine is going to be so churning on trying to pull logs, and so it took me a while to realize what was the guy that was the bad guy, that was the bad guy. So if you ever find that being your case, either you don't build it with the logging server or shut the logging server down, and you'll find that you can actually use it on your laptop. So you can actually get away with using, just with two actual virtual machines running in VirtualBox, you can actually run it. Now that doesn't include running Swift. Swift is a separate conversation, but all the other core components you can actually use just off those 2 instances.
I was actually talking about the lab environment where physically I have 2 very powerful hosts. Is that enough or not? I can avoid the elk stack.
Right. I mean, it is, and that's the thing about why we chose Ansible is that to make it as flexible as possible, you can run it on 2. Our reference architecture is not that, but again, if you just want to play with it, you surely could. You know, having 1 server dedicated as what would be considered infrastructure server, and then 1 server for compute. Obviously, you won't be able to do block storage or object storage, but you will have a functioning OpenStack Cloud minus those components. Any other questions?
What kind of support is there for audits and logging? So, you know, are you able to either generate reports and or look at logging audit trails of when the last time Ansible was run and what sort of changes would apply?
So, truth be told, open and honest and transparent, I can't say that we have a really good log as to what was run and, you know, what happened. Yeah, we just didn't do a good job with that. I'll be honest about that. If you're not sitting watching the screen, or if you didn't wait for the output to come out to tell you what nodes failed or what failed, you may not exactly know where it left off at. And again, that's something that I'll look into because I've run into that. Hopefully it's not about logging.
Well, no, but in your Ansible CFG, you can enable Ansible log on your control machine so that it basically captures all of the output. Now, it may not necessarily be great for auditing because you're actually looking at the JSON output, but it will record what you want. Just depends on your Ansible CFG file. There's no reason you couldn't send that to Elk, right? There's no reason, or using Logstash or something like that. So, and also on each node, typically, if it's making changes, it's going to be getting something in the syslog as well. So if you're installing packages, that's going to show up in the syslog. So while not perfect, there's some information out there. So available.
Yeah, I mean, other than the fact that if something critical fails throughout the install of the playbooks, it will stop. It won't just keep going. If it's something minor, it may keep going. But yeah, all those native traditional ways are good. But separate from that, no, we didn't do any really good logging around that. Yes.
Have you tried running this with like Ansible Tower for getting all of kind of like the logging and auditing that you get with that? Like, will these just run out of the box, or do you need to do any more?
Well, you know what? I can get you a good answer on that. Our training team does use Ansible Tower to use these playbooks to deploy environments when they're training individuals. I've actually physically seen them do it. I'll ask them if they had to make any modifications. My gut tells me probably no, because they're very well written, very well orchestrated. 9.0 was okay. 9.1 was a little bit better. Now we're at 9.05. That's like perfect. and now we're about to be on to 10, which I'm assuming is just going to be better. So we've actually, just over the time that we started doing it, probably about May of last year, we've greatly improved as to making sure those playbooks are rock solid, can continuously run, not run into these little weird things, so things like that. Yes?
I got a little lost on the containers. My experience with containers is limited to Solaris.
That's fine.
So I don't know how you are going to use the LXC containers here in this OpenStack bare bone machines. How are you going to use it? I couldn't understand.
Yeah. It took me a minute to wrap my mind around it too, but the reality, the thing is, so on Ubuntu 14.04, then one of the native components is LXC, which was, as some people would say, the first Linux container that existed way before Docker. But, and that's why we chose LXC, is because it's been around a lot longer and Docker has not, and we needed something reliable. The reality is when you create a container in Ubuntu 4, you can assign that container an IP address, and it's actually like logical space running inside of your OS. So what we do is we take a big cache of all the containers that need to be created, and that's actually up on our Git repository. So when you're actually running your playbooks, it's pulling down the caches of those repositories, which are already pre-built containers. So we built them, we took them off, put them off to the side, put them up in a repository. So when we're building it over and over again, we're just pulling down those repositories. And I can, I'll give you a...
Conceptually, LXC isn't really any different than the Solaris containers. I mean, you're essentially, it's like, in the simplest terms, imagine the old FreeBSD jails, where you're just essentially CH rooting, you get your own memory space. LXC is really nice because you can essentially have different versions of libraries, and there's no interaction between this container and the host or other containers.
Only certain kernel-related features are not available. But what I didn't understand here is, how are we using it in this deployment? That's what I didn't understand.
Oh, I see. So, so there's lots of processes, right? So you have like a web server that runs for the web UI. All of that is running within an individual container. So each, I take it like Cinder is its own, the Cinder API is its own container. Cinder volume would be its own container. Like, and then they're basically all just using RESTful APIs to talk to each other. Like,
okay, so isolating these OpenStack components is what we are isolating them through the LXC containers.
Yes.
Instead of my previous Havana install using the Puppet install script, RDO is what I use.
Yes. Yeah.
So it just installs, puts everything in one machine. But in this methodology, we are separating them using LXC.
And we could run those containers on multiple machines if we wanted to, right? We don't have to necessarily run them all on one control node.
No, and that's why we actually create three control nodes that are all running the same containers behind a load balancer. So that's just giving you that high availability, right? But you can run it on less than 3, you can run it on more than 3. Actually, what we recommend is when you get over 200 compute nodes, you need to add more infrastructure nodes to that to be able to handle just the throughput, because OpenStack is very chatty, the APIs are very chatty, they constantly talking back and forth over the network. You don't realize it, but they are.
And very loggy also.
Very loggy, very chatty. That's why we did the whole OpenStack. So what I did is I'm SSH'd into our infrastructure node, and I just did an LXC, LS and fancy, just to show you the containers. These are all the containers running on the infrastructure node, and as you can see, every component in OpenStack has its own container. Cinder, Galera, Glance, Heat, Horizon, Keystone, Memcache, Neutron. They all are in different containers, and they all have different IP spaces. And I can control from this infrastructure node, I can stop and start a container, which basically I'm stopping and start a component of OpenStack. But the base server that I'm on knows nothing about OpenStack. And that's the power of being, so when I want to go do upgrade, I just pull down from cache a whole bunch of new Juno or Kilo containers, turn these guys off, do some database behind the scene magic, and we're running the next version of OpenStack. So that's the power and the reason why we did that.
Are you gonna have something for Salometer?
Salometer, yeah, Salometer is always a favorite topic for me. So, our next release, which is version 10, which is coming out in February, will include Salometer. I'll explain why we did not include Salometer in our previous release. So, Salometer, if you're not familiar with it, is a project that basically helps you do chargebacks for consumption of cloud resources, right? It basically pulls down all the stuff from all your compute nodes, puts it in a centralized place so that you can actually analyze that data and figure out what tenant is using what. An example of that is a lot of people want to use it to be able to charge back different resource groups within an organization for their consumption of the cloud. Right? The reason why we did not include with our ISOP release Salometer is because we didn't feel it was a mature enough product. and I explain why. So when we found it, when we started deploying that Salometer on clouds that were larger clouds, we found that the database that was using to back Salometer originally wasn't fast enough to keep up with all the data it was being written to. And what it was doing is actually causing skewed numbers and inaccurate data. And us being a customer-facing company, we can't. It's the wrong thing to give a customer a capability that we know is giving the wrong data. That just is not going to work. So we made an executive decision to pull it out of our Icehouse release. Since then, good news is the OpenStack community has made a lot of progress. They are now allowing you to be able to have different backends to Salometer. I think Mongo is one of the options. And there are actually, I think, 2 other options. We have a database behind it now. So we're bringing it back for our next release, and we're going to recommend not running it in MariaDB, but on a different backend. And that'll also be part of our reference architecture. Of course, we're not going to expect you guys to figure that out, but that's where Salometer sits. Yes?
Not an Ansible question, more of an OpenStack question. I really hate databases. I really hate databases. I hate MariaDB. I hate having to use Galera if I want to make it, active.
Yep.
How do I rip out MariaDB and put in like a key value store like Redis or something else?
I don't know. I don't think the OpenStack community has gotten to the point where they're doing that yet. That would be nice, but I don't think we've gotten there yet. Again, we moved away from MySQL to MariaDB for obvious reasons, Oracle. But that's just unfortunate. It's one of those costs you still have to bear for now. I don't think there's anything in the community yet about using those other key stores or data stores to back OpenStack. Sorry. Yeah, it kind of sucks.
So I got a question about Ansible. Sorry. Given that where Rackspace is and the type of consumers that you've got, I understand for the private clouds, going into a data center, you execute these deployments, you presumably hand over the deployment scripts to the customers, and then it's their kind of responsibility.
Kind of true, but I'll let you finish.
Right. So for the cases where there's a support, or for the public cloud where I doubt that many people are actually going in and installing OpenStack on the public cloud, but for those sorts of cases where you've got responsibility for it, how do you handle when customers have gone in and kind of screwed things up, right? So they've made some big change directly somewhere that's not really part of the playbook. How do you either determine that that's occurred, or as opposed to say Puppet or something, which is its job is to basically the infrastructure dump and it just continually redeploys any changes and corrects anything that anybody might have done accidentally. Right.
So, I mean, we take 2 approaches, and it's one thing I just want to be clear about is that the difference that we offer our customers is that we actually will support your OpenStack environment. If that was something you were interested in, we will support it and give you a 99.9% SLA uptime on your OpenStack environment. And that is an option you can buy. That's considered our core support, where we will actually maintain your cloud for you and you're just a consumer. The way we kind of protect ourselves from having a customer do that is, they have admin control to the cloud, but not necessarily admin control to all the components of the cloud. So we're protecting them from themselves, so to speak. Yeah, I mean, they can go in, create tenants, create users, they can all do all that fun stuff, but if they wanted to change like a vCPU ratio, they can't do that. Because we have not given them the access to be able to go into that deeper level. Now, if they said, hey, this is our cloud, we want complete control over it, we don't want your help, then obviously we give them the keys of the castle and we walk off. Of course, if they call us, we won't turn them down, but it makes it a difficult type of relationship. You always have escalation support, is what we call, where you can phone us and it's like phone a friend. We'll help you to fix your problem and then we'll go away again. So that option exists too, but we'll do either or. And we'll do it not just in your DC, but in our DC. It's the same in either way. Nothing changes about the offering, support offering.
So basically there's not like a persistent process. Like basically you say, this thing's changed. Do
you guys like schedule the Ansible playbooks to run all the time or anything?
No, because again, the level of control we give to the customer, they really can't mess up OpenStack per se. Now, don't get me wrong, they can spin up an instance and try and delete it immediately and get it stuck into that deleting mode and it never go away. Stuff like that, it is what it is. But as far as the system itself, they can't really. And as well as we also take the deployment server and we put it to the side. So it's not readily available for them to even run the playbooks again. And we don't actually have to run the playbooks again. It's actually been pretty good so far. Yes.
Um,
Sorry. You know what? Sorry. Yeah.
Are the Juno playbooks ready to use? I know they're on Git.
I have not done it yet, so I'm going to say no, but they're there. And because I was told that it's actually going to be launched in February, I'm actually going to go take a look at them. So feel free to give it a go, but don't be disappointed if it doesn't go the way you want it to go.
So I remember when Rackspace, or not Rackspace, when Ansible started like doing things like Fireball support, so like when you have SSH scaling issues, and how many nodes do you guys usually run into where you actually have to enable something like Fireball mode to get like nodes up in a quicker fashion than just the underlying SSH? Like what's the, you guys have seen your deployments, like what's the breakpoint?
I mean, we've done testing. We've actually benchmarked up to 200 compute nodes. And I think they stopped there because they felt that after that it starts to turn into a much bigger thing with OpenStack. So I would probably say up to 200 nodes. And that's compute nodes, so if you add the whole environment in, we're talking about 204 servers or 210 servers, somewhere in that range. But I mean, yeah, after that then we start to distribute things out, because in OpenStack there's things called cells and regions, and so then we start doing other fancy things once you get past that point. To avoid that. I think one of the reasons is to avoid problems like that.
So into the details of, sorry, I just started speaking. Into the details of networking, neutron stack and configurations, there are open switches and different components and different ways you can configure, you know, the VLAN IDs are different. So how do you make modifications? You make modifications to the playbook. Does it have, is it well documented that you can make those modifications? Or?
Yeah, so part of that 65-page document, the 35 pages that I spoke about, is actually going into some of the detail around how the networking has to be. We require, in our data centers, 3 bonds that have to be created to actually build, so you have to have 3 individual bonds, so you actually have to have 6 NICs. And they're 2 of them are bonded together to be able to deploy our private cloud. If it was in your DC, we require 2 bonds. We have a 3rd bond for another reason, but yeah, that document actually goes into the details. And we're actually using Linux Bridge. We're no longer using OBS.
Okay.
So that's another side. Yes.
I have a question for Ansible.
Sure.
You mentioned that you guys do deploy, right?
Yes.
So say if I have a Rails application, and I'm using Ansible to deploy, you know, you can use Capistrano, and Capistrano create all these magic things it does for you, and if you were trying to replace it with Ansible, how do you delete all these files that Capistrano will create, those releases? How do you auto-delete them with Ansible? Because right now, I'm just asking, because I see people doing it, it's like manual delete. How do you do?
Gotcha.
Just like Capistrano would do. How would you replicate that?
Yeah, I have to open that up to the other guys, because I don't have a good answer for you. Because I'm actually not, I gave up development a long time ago. But anybody is familiar with getting rid of some of those files?
I'm not a Rails person, so no, more the infrastructure side.
I've seen a post actually talking about specifically that. I'll post in the comments for this meetup to the link to the article that actually talks how to replicate Capistrano's deployment system in Ansible.
No,
including the cleanup of the previous phase 10.
Cool. There you go, magic.
Yeah.
Sorry I wasn't able to answer that, but I'm definitely not the guy to answer that question, for sure.
Can you actually go into, I don't know if you have actually contacts with the people who are actually, you know, making the actual Ansible module for the OpenStack components. I take it that it's probably going to be something that has some collaboration with Rackspace. Can you just kind of talk about it a little bit in terms of if you know of any sort of like roadmap in terms of what they're going to cover in the next modules or whatever it is that's coming up?
Gotcha.
And why is it, you know, kind of you go back, like there are some proprietary modules that you guys use that you aren't publicly available. How do you basically make that differentiation and whether or not there is going to be an open source path to those modules?
Gotcha. Well, first and foremost, I'll say that every module we create, it's all open source. We don't proprietarize anything that we do. And I can kind of come back or put some information out there because I don't have that information, but I can get some information for you as to the roadmap around it. Right now, our deployment is actually building off of an older version of Ansible. We're not even using 1.8 now. we're like 1.6 or something older like that.
Yeah.
And that's primarily because we had to standardize on an A version of Ansible to build these scripts, right? Version 10, we may have bumped up the version in Ansible, but again, I can get some more details around how they're partnering with Ansible and what they're doing behind the scenes.
Yeah.
I'm sorry, I just don't have.
Yeah, I mean,
that.
those kind
Yeah.
of, I mean, just in basically, I mean, I don't have to work with OpenStack, but I think this is probably a general question, which is how do you basically deal with version changes, right? I
Right.
mean, with different Ansible versions, it's kind of like all of a sudden you upgrade, oh, this module doesn't
Right,
work anymore,
right,
so.
Right. And that's why we standardize on one. I'm sure there's a whole bunch of regression testing to move forward because they don't want to stay behind. That's another reason why we went with Ansible, is so that we can keep upgrading in isolation and not affect what we did previously. So even with version 10, if we decided we wanted to go with a newer version of Ansible, it's no problem because we push Ansible to the deployment server. So the deployment server is actually one that's going to manage that. And that's how we kind of keep that from being a problem. Even when they roll forward, if the deployment server is running an older version of Ansible, so what? We tear it down, we build another deployment server, and we push with the new version of Ansible. So that's kind of how we're kind of mitigating that for now. But that's an interesting question. I can pose that out there. I have a buddy of mine who I'm following him, and he's following me on Twitter. That couldn't answer that question, so I'll get some answers for you. He would love to answer that question. The same guy who gets the bugs.
Do you guys take pull requests for your cookbooks and or your roles in your playbooks and stuff like that?
We can't say cookbooks. Chef is bad. No, I'm just kidding. No. We absolutely will take pull requests. We absolutely will take bugs that are reported and investigate. It's funny because when I was first started, I didn't really know anybody at Rackspace, so I'm trying to deploy it and I'm running into problems, and I got on the Git and I complained about something, and like a couple minutes later I get an email in my inbox. It was like, "What are you doing out there complaining about stuff?" I was like, "But it's not working." They called me next time. I was like, "Okay, but I didn't even know you existed." They're very reactive. If you run into a problem, they will immediately jump in there and respond to you. Actually, it's shocking how quick they respond to you. They live in there, and yes, they do take pull requests. That's one of the reasons why we were very happy to get it out of the stack for it, just so that now it is ultimately is a community product, no longer just a Rackspace product. Yes.
Just a question. Given the experience that you've had deploying lots of different OpenStack instances for different customers with different configurations using Ansible, what amount of variation exists? Is it like large or small in terms of the configuration for each OpenStack instance? So, for example, whether you're using 1 gigabit or 10 gigabit or 40, what's the InfiniBand or something? Is there different? Are the playbooks? Do they have how much sort of intelligence do they have about the how to optimize based on the target solution, or is it a fairly generic, one-size-fits-all type of a setup?
It's the latter of what you said, actually. It's a one-size-fits-all, and I'll tell you why. At Rackspace, we standardize on 2 different types of server hardware that we push our private cloud on, and because of that, we know the 2 standardizations, but the playbooks themselves are very generic. There are requirements. The biggest requirement is around the networking bonds. If it goes to run the playbook and it doesn't see the 3 bonds that it expects to see, or the 2 bonds it expects to see, it will stop running. And it will give you a message that it failed, but it won't say, failed because you didn't give me my network bonds. It'll say some other random error message, and you'll be looking at it and like, what is it talking about? But, and that's why the 32 pages of pre-configuration work is so important, because they're explaining why those bonds are needed, to be able to do neutron and be able to segment out traffic for the API management, segment out traffic for the host management, because you'll find that with OpenStack that became a problem. Trying to put all that over 1 NIC or 2 NICs just didn't work out very great. And I'm talking about, not just for smaller clouds, but once you start going 22, 70, 100 compute nodes, it turns into a whole nother monster. So we built based on that. Is it really annoying when you're trying to build it on your laptop and you have to go in and trick VirtualBox to create all these NICs for you? Yeah, it is. But we had to standardize in one way, and the network one is probably the biggest annoyance that you'll probably run into. I call it an annoyance.
Okay, but so for your production customers, how much follow-up or tweaking or customization is needed to be able to tweak all the performance for their particular setups? So suppose one customer is huge into Swift and they are all about storage, and the other customer is all about compute, and all they care about is financial transactions occurring memory really, really quickly. Is there a wide variation in the configuration of OpenStack that then has to be followed up after the initial install? Or?
And this is where this variable file is your friend. That's the guy that will do all the variations that you want to speak about. If the customer doesn't use Swift, you basically comment out the lines in this file that refers to Swift nodes. If they want to use Cinder, but they want to have multiple backends of Cinder, that's the file where you will go in and define additional backends for Cinder. If you want to have 10 compute nodes versus 1, this is where, so this is the file. This is the guy that dictates. So it's in one place instead of going and running around to different places. Before the engineer actually deploys that private cloud, there's a pre-deployment or there's a deployment document that me as an architect I have to provide. And it tells the engineer, okay, this is how many compute nodes are they going to use Cinder? If they're going to use Cinder, is it going to be NetApp? Is it going to be EMC? Or is it going to be Cinder nodes? Are they going to use Swift? How many Swift nodes do they need? And they take that document and basically go in there, plug that information into this file, and hit go. And that's it.
Wow.
Yes?
Okay. I'm Ansible user, and I'm very interested in dynamic configurations. For example, dynamic inventory. And from that perspective, have you used some kind of dynamic variables? So just not to store in the files and get these variables from some backend.
Yeah, so these playbooks actually do a lot of that, primarily around the containers, right? Because there's no way for us to determine what IP a container is going to have, or even exactly naming it ahead of time.
Yeah.
You can standardize on it, but you can't exactly know. There is a lot of dynamic inventory that goes on. So in this file, you have to tell it bare bones stuff like compute node, the name, the IP address of the compute nodes, the IP address of the infrastructure nodes, the IP address of the Cinder and Swift nodes. You have to tell it that. That's not dynamic. But then after that, everything else that it does, it's dynamic inventory of pulling up all the containers, the IP addresses, where they are, whether they're running or not. There's some other dynamic stuff that's going on. So yes, these playbooks do use dynamic inventory. And what you'll find is that after you get finished running it, let's say for example, you go into this file and you make a change and you run the playbook again, you'll find that sometimes it doesn't, it's still using the old stuff because it is using dynamic. And you have to kind of kick it and tell it, all right, I need you to clear your cache and then pick up the new variables that I just gave it. So yeah, so it is, so again, you can rip it apart, you can see it, but yeah, we're definitely doing a lot of dynamic inventory, primarily because of the containers. Yes?
I think similar along those lines, are you finding that Ansible is the right tool for orchestration, or do you think there should be another tool for that? I feel like there's so many different ways to like spin up new nodes. Do you feel like Ansible is the right tool for that, or like Terraform or something else?
I mean, honestly, I put it to the test. I mean, I feel that I've been able to do everything that I needed to do with Ansible, and tacking that onto, there's some things that I'm missing in Ansible that you may have to use other tools for, such as remediating issues. So, if you have a monitoring system and you detect that it has a problem, you could have it call a playbook to kind of remediate it, but it's not really interactive, right? They'll just run it, and based on the result, you can maybe determine it's fix the problem or not fix the problem. I find that I've had to partner with other tools like StackStorm and things like that to kind of help with some of the remediation of things. But as far as orchestration goes, I haven't had a need to go outside of Ansible.
Too much.
So I've been able to do pretty much everything I needed to do, from spinning up instances, configuration, installing software, restarting servers, everything you can think of, I've been able to do without any problem. Yes.
Are these playbooks going to support the proxy environment that we have to deal with in enterprises also?
Now, when you say proxy, you mean
going out to internet through a proxy.
Yeah.
We have authentication and Windows.
Yeah, that's yeah. So right now, it is no real solution around that right now. It does need to get out to the internet to pull down the repos and the containers and cache. That's something I could take back and talk about. Right now, we don't have like one big, it probably would have to be a small drive. It couldn't be a thumb drive. We don't have like a small drive that we can just say, here, you can go and install it. Could we figure out how to do it? If we had to, yes, we could.
I think the hard part there is knowing what all of the other dependencies that you might, because typically so again, I have to do all this with Chef, but if you're running like a CentOS or a RHEL versus Ubuntu or Debian, the packages you may need for one of the dependencies may be different, and trying to calculate what all of those could potentially be, I think, would be not impossible, but it would certainly be challenging for somebody like OpenStack. But
yeah, I was recently, I was in another country, I won't say, because they probably might get mad at me, but I was in another country and they asked me the same thing. Their data centers do not have any public accessibility whatsoever, and they wanted to install our private cloud. And can we figure out how to do it? Yes. He wanted to do it like ad hoc, like, oh, I just want to, do it just to play around with it. It was like, okay, that's a lot of work just for you to play around with, but we could, if that came down to it, we could figure out how to do that. But like you said, there's tons of repos, not just repos that for us, but there's repos OpenStack. There's different components you need to install. Like it would be, like I said, it would be, small drive that you would have to walk in there with, like probably almost short of a terabyte of space to do it. So
yeah, it took some time for me to do in Salt Stack. That's what I was using at the time.
Yeah.
With Puppet, obviously, for the audio stack and for the
Lots of
base
tunneling tools.
But
yeah.
But yeah, it was tricky, and every tool will have its own rate. So
how easy is it? One of the asks from my developers that they really be able to deploy to AWS or our local OpenStack or over AWS and launch it. Have you seen people doing that?
So just frame up your question for me again. So using OpenStack to talk out to other clouds, or to kind of be the orchestration between.
Or using the same API calls that they use now in AWS.
Well, there was some backward compatibility with OpenStack to be able to leverage the AWS API and the OpenStack API in the same way. I think that they kind of removed that a little bit. I don't think they're really doing it anymore. But the reality is, from OpenStack, could you orchestrate it calling out to other public clouds to do things? You could, but you probably would have to use another tool like Ansible or something like it. There is no interchangeability in OpenStack to Amazon. It used to be some, but I don't think that that's as popular anymore.
Wasn't the functionality of heat, right? So when my application gets hot, it will automatically scale up. But can it scale up and scale out to other clouds?
Well, and again, that's one of the myths that are out there is heat does do that, but it needs telemetry. So you need heat and telemetry to do scaling. You can't do one without the other. Like, you need both of them together. And in essence, what you said is accurate, but at the same time, without the two, you can't do it. Now, with heat, you can write HOT or HOT, heat orchestration templates. You can write templates to be able to spin up resources outside of just your OpenStack cloud. But that you can do it, but you have to explore looking at heat and looking at heat templates to do that. But if you want to do auto scaling or scaling, you need telemetry. All right, before we're just gonna, well, you know what, keep asking, it's fine.
Isn't happy?
No, folks are leaving, I wanted to say goodbye, but it's cool.
So, I imagine this playbook, well, multiple down, really complicated. And when you make any change, how do you ensure that the change you want to actually happen? So do you use EDD or how else?
Well, I mean, I have made changes to our playbooks to do different things, primarily because of deploying it locally on a laptop. I had to make changes to like some of the base configurations for MariaDB, and that's all embedded inside the playbooks. I mean, honestly, using Ansible is very easy, and our playbooks are written where it's not a lot of dependencies. So if you make a change here, it's going to go affect a whole bunch of other things there. It's pretty straightforward. We use a lot of roles. We use a lot of roles over and over again. So generally, if you get the right role that you need to go after, you're generally safe. But we don't really do anything else, in particular on top of that. You kind of have to know. You kind of have to know where to poke and make changes at to kind of get through it.
Like to ensure that the change that you want to actually happen. Like you don't use something like RSpec or.
You know what? Honestly, I couldn't tell you. I'm sure those guys do something when they're regression testing all of their playbooks. I'm at the end, I'm more of a consumer and a judger than a creator of the original playbooks. Now, if you're talking about my playbooks that I wrote, then I can tell you. But yeah, no, the other ones are a lot more complex.
What about your playbooks?
Well, you know, my playbooks, I just keep running them over and over again, so it does what I want it to do. And I have probably built and torn down OpenStack Cloud within my 6 months of working at Rackspace probably 2,000 times. That's just the nature of the beast. But yeah, I don't particularly use any tool. I just
hang on until it works.
Yeah, I know it doesn't really sound the greatest. It's not slick, but it is what it is.
So, I mean, you talked previously about how at, you know, at Rackspace they had a conscious decision to switch over from shell. Like, I mean, there's a lot of, I would imagine that basically, you know what, you know, if it already had an investment in infrastructure, they just kind of keep going. There has to be a reason. I mean, can you elaborate a little bit on that?
Well, yeah, I mean, the idea that we had to build a Chef server for every private cloud and pray that Chef server came up and did what it was supposed to do, and then pray that all the cookbooks worked with that version of Chef server that we brought up. You know, it was lack of a better word, a nightmare. You know, we didn't have a really big set of employees who knew Chef well enough to keep tweaking it and making it something that was durable. And it just got to the point where no one wanted to deal with it. And I'm being perfectly honest. And that's where they had to really make a hard decision and say, well, either we can keep down this path where nobody wants to keep dealing with it, no one wants to manage it, or we can go with something that anybody can deal with. And when I say anybody, you know, you have multiple tiers inside of, you know, Rackspace. You have the guy who's maybe writing the playbooks, and you have a guy who's building the cloud, and you have an engineer who's actually building the cloud, because I don't actually, like anything in our DC, I'm not responsible for building. If it's a customer on-prem and it's a professional service engagement, then they'll get me and have to deal with me for a week. But anything in our data center, it's actually engineers who do that, and these engineers aren't senior engineers, right? They don't have the expertise to troubleshoot Chef or Cookbook or any of that stuff. So that's why we made the decision to go with Ansible. It made it easier that if an engineer had to make a change to something, particularly for a customer's cloud, he didn't need a senior or a high-level engineer to come in and make those changes for him. He can just make the changes in the playbook. And like I said, every deployment server that goes with the cloud is siloed. So he can make those changes on that deployment server until he's blue in the face. It won't affect anybody else's cloud. And that's one of the reasons. Chef it was very difficult to do that. Yes?
The containers that you have on GitHub, have they been pen tested and all kinds of stuff?
Like hardened and things like that? Yes. Yeah, I mean, and again, this is where, you know, they have been to a certain degree. Our clouds are called, private clouds are called private for a reason, is because they are siloed off from everything else. And any outside connectivity in is determined by the customer, so he will determine what he wants as far as his firewall, what he wants to allow in and out. But they're using the best practices of Linux at the current moment. I'll say it that way.
So no calls to canonical?
No random calls to canonical. No, none of that. Okay. None of that. Because once we deploy your private cloud, you know, we always recommend a firewall, a physical load balancer, and you determine what rules you want to find. And if we didn't have it that way, then we would be screwing us, right? Because if the server was trying to make calls and wasn't getting out, the server could then be having a problem, or the cloud wouldn't be functioning. So no, all that stuff has been patched up and fixed so that if the customer never wants the cloud to be publicly exposable through the public internet, it'll never be.
So how do you handle patch management as vulnerabilities that are discovered in the wild?
Good. So if it's a vulnerability that's more of a security thing, we basically roll those out immediately within our private clouds. You know, and that's pretty much across the board. I don't know if you guys, a couple months back, that whole big Linux vulnerability came out, and we had to roll.
And Heartbleed.
Yeah, Heartbleed. Yeah. So you know, we do our best to very quickly roll those out across. We did that very quickly across our public cloud. I mean, we got some flack about doing it, but
you're not responsible for the underlying patches, though.
You mean the OpenStack patches or the OS patches, or both?
Both. If it's a security threat, we will handle it immediately. If it's an OpenStack patch that's not a security threat, no, we do not apply those immediately. We either wait for a major release, or based off the customer's need. If the customer says, hey, you know, I'm having that exact bug that's been now fixed, we need to apply that to our private cloud, we will work with you to apply it. So as long as it comes from the OpenStack community, it's cool. If it's something custom you wrote in your basement and you want to give it to us, we're not going to. Because then it's not supportable, right? Like we have to be able to support everybody's cloud the same way. We can't have this special cloud, the Snowflake cloud over here, Snowflake cloud over there. Like that's not a sustainable model. So. Cool. You guys, I questioned you guys out.
Yeah.
Thank you. Thank you.
Thanks for having me.